All right, welcome back everybody. In this video, we are going to talk about concepts related to section 5.6 of AP Calculus, determining concavity of functions over their domains. This is the second video in this lesson. We've already talked about concavity and done a couple of examples, so we're going to pick up right where we left off. We have a couple more examples to look at related to concavity here. We're going to go ahead and start here with example 3. Given the graph of f prime, find the x-coordinates of the points of inflection and state the intervals of concavity. Okay, so realize in order to talk about concavity, we're interested in where f double prime is greater than 0 and where f double prime is less than 0. F double prime is the slope of this graph. Okay, so this graph is concave up when the slope is positive and is concave down when the slope is negative. Okay, so I'm just going to go ahead and build the intervals as I talk my way through the problem. I tried to write concave starting with the letter N. It's concave down. Okay, so we look at these pieces, and this first piece right here has the same slope all throughout, and that slope is negative, which means that the graph is going to be concave down on that interval, so concave down starting at -4 and going over to -1, at which point the graph changes slope from negative to positive, which means that on that interval, the graph is concave up, the graph of f. So that's going to be from -1 to 1. The function f is concave up. And then we're back to a negative slope between 1 and 2. So it's going to be concave down from 1 to 2. And then finally, we're back to a positive slope from 2 to 3. So it's going to be concave up from 2 to 3. Now all these x-coordinates where the graph changed slope from positive to negative are the x-coordinates of our points of inflection. So the x-coordinates of our points of inflection are at x equals -1, x equals 1, and x equals 2. And there's everything for example 3. All right. And our last one here, example 4, adapted from free response question number 5 from the 2015 AP Calculus AB exam. It says the figure to the right shows the graph of f prime, the derivative of a twice differentiable function f, on the interval from -3 to 4. The graph of f prime has horizontal tangents at x equals -1, x equals 1, and x equals 3. So we're going to answer a few extra questions here that tie into things that we've already talked about in previous lessons, not just in this lesson, but in previous lessons. So we've got the graph of f prime here. Let's start with our first question. Find all x-coordinates at which f has a relative maximum. Give a reason for your answer. So if you remember back from when we were talking about relative extrema, we have a relative maximum when the derivative of the function changes from positive to negative. Okay? And if we look at the graph of f prime, which is the derivative of this function f that we're talking about, we only need to find where it changes from positive to negative in order to find the x-coordinate of a relative maximum. And that only happens at one place, at x equals -2. And my reason, because f prime of x changes sign from positive to negative. At this value, so it is a max by the first derivative test for relative extrema. Which we learned a few sections ago. Okay, done with part A. Part B. On what open intervals contained in the interval from -3 to 4 is the graph of f both concave down and decreasing? Okay, so let's talk about this. In order for it to be decreasing, that means f prime of x is negative. Okay, f prime of x is negative on the interval from -2 to 1 and the interval from 1 to 4. That's where f prime of x is negative. It's concave down when f prime is decreasing or when f double prime is negative. F double prime is the slope of the graph of f prime. So f double prime is negative for -2 to -1. That's where the slope of the derivative graph is negative, and then it becomes positive again, and then the slope of the derivative graph is negative again from 1 to 3. Okay, and I'm going to say that's because the slope of f prime is negative. Okay, now we're looking for the overlaps of these two intervals. Both of these characteristics occur. For -2 to -1 and 1 to 3. And so that is where f is both concave down and decreasing, because f prime is less than 0 on the graph. Fill that information in there. All right, last one. Find the x-coordinates of all points of inflection for the graph of f. Okay, so points of inflection happen where f double prime changes sign. Where f double prime changes sign. F double prime is represented by the slope of this graph. Okay, since this is a graph of f prime. So f double prime is negative from -3 to -1. F double prime is positive from -1 to 1. So that means that we're going to have a point of inflection at -1. F double prime is negative from 1 to 3, since the slope is negative, which means we've got another sign change in the second derivative right there at 1. And then lastly, f double prime is positive from 3 to 4. So we have one more spot right here at 3. And so the x-coordinates, x equals -1, x equals 1, x equals 3, and give a reason for your answer. These are points where the slope of the graph of f prime changes sign. Graph of f prime changes sign, indicating a sign change for f double prime. Since f double prime is the slope of the graph of f prime. I feel like I talked myself in circles there a little bit, but I think that's a good enough of a reason for us. All right, we've reached the end of this video and the end of our lesson on determining concavity. And so go ahead and work on some practice problems, get yourself better at this, and we'll see you next time when we talk about stuff from section 5.7, which is using the second derivative test to determine extrema. Okay, we'll see you then. Have a great rest of your day, everybody.